Hello and welcome to the Chemistry Solution. This tutorial is on naming ionic compounds. And in this tutorial we're going to focus on naming binary ionic compounds. And I will also include some examples where you have formulas with transition metals. And you have to use a Roman numeral in the name. Remember that ionic compounds typically consist of a metal and a nonmetal. They always consist of a positive ion or cation and a negative ion or anion. And this tutorial will focus on binary ionic compounds. This means ionic compounds that consist of only two different elements. First, let's talk about naming the cation. This is the best part about naming binary ionic compounds. The cations that are formed from metals get to keep their own name. So the potassium ion with a charge of +1 is just called the potassium ion. Strontium +2 would be the strontium ion. Aluminum +3 would be the aluminum ion. There are a few cations that are a little bit more difficult to name, and that happens when you have an element that can form ions with different charges. These are usually the transition metals, lead, and tin. And then in general, the ones that you can exclude from this group would be silver, which always forms ions with a charge of +1, zinc, which always forms ions with a charge of +2, and cadmium, which always forms ions with a charge of +2 as well. When you have one of these metals in your compound, you need to have a way to distinguish the specific ion that's in your formula. There are two different ways to do this. The most commonly used method is to use Roman numerals in the name to identify the charge of the metal ion. For example, if I had a copper +1 ion, I would call that the copper 1 ion. If I had a copper ion with a charge of +2, I would call that the copper 2 ion. An alternate way to do this would be to use the endings ic or us to denote higher and lower oxidation states. This method isn't used a whole lot anymore, so in this tutorial, we will just be using Roman numerals to identify the charge of the metal ion. Okay, that about covers how to name the cations, so let's talk about how to name the anions. Remember, the anions are the negatively charged ion in your compound. In order to name monatomic anions, you drop the ending of the element and you replace it with "ide." So when oxygen gains 2 electrons to become the oxygen -2 ion, we call it oxide. When chlorine gains an electron to become the chlorine -1 ion, we call it chloride. Okay, let's look at a few examples. In this first one, I have CaBr2. Remember that the cation gets to keep its own name. So we'll name the cation calcium. For the anion, we take the name of the element, we drop the ending, and we change it to "ide, so this would be bromide, calcium bromide. Moving on to Al2O3. Again, the cation gets to keep its name, so we have aluminum, and for the anion, we change the ending to "ide, so oxide, aluminum oxide. For the third example, Mgs, we would have magnesium sulfide. So again, the cation keeps its name, the anion we change the ending to "ide. And for my last example, we have lithium nitride. What you probably notice about these names is that the names don't depend on the number of each type of ion. This is because ionic compounds form in such a way that the overall charge is neutral. So the sum of the positive charge from the cations has to equal the sum of the negative charge from the anions. Because most elements only form ions with a particular charge, they have to combine in specific ratios. And if you want more information on this topic, go ahead and watch the tutorial on ionic compounds. In that tutorial, I discuss how to determine the empirical formula of a compound formed from two different types of ions. Okay, so hopefully what you're realizing right now is as long as you don't have a transition metal, if you have an ionic compound, that's made from only 2 different types of elements, naming the compound is fairly straightforward. The cation keeps its name, the ending of the anion gets changed to "ide." We're going to add just one more step in here when we name ionic compounds that have a transition metal in the formula. And the other 2 metals that we normally need Roman numerals for would be lead and tin. For these compounds, you need to determine the charge of the metal ion. Remember that this is the value of the Roman numeral that would be used in the name. A common mistake is that the Roman numeral is used as the number of the metal ions in the formula, but that's not the case. The Roman numeral is the charge of the metal ion. In order to do this, we need to use a little bit of deductive reasoning. Remember, the overall charge of an ionic compound must be neutral, so the sum of the total negative charges from the anions must equal the sum of the total positive charge from the cations. Let's take a look at a couple examples. Here we have the formula CuCl2. If I want to determine the charge of the copper ion so that I can put that as the Roman numeral in the name, I first need to know the charge of the anion. I know that chlorine tends to form ions with a charge of -1. Let me show you how you can figure this out. You can look on the periodic table. Remember that most atoms will gain or lose electrons in order to have the same number of electrons as the noble gas closest to them. That is, most atoms like to follow the octet rule. That means that all of the atoms in the second to last group on your periodic table tend to form ions with a charge of -1. Okay, so we know that chlorine likes to form ions with a charge of -1. You'll also notice that there are 2 chlorine ions in this formula. That means that the total negative charge from the anions is -2. Knowing that the overall charge on an ionic compound must be neutral, that means that the positive charge on the copper ion must balance out the negative charge from the 2 chloride ions. That means that the charge on this copper ion must be +2. So this is the number that we will use as a Roman numeral in the name. The name then for this formula would be copper 2 chloride. So all of the other rules stay the same. The cation gets to keep its name. The anion, the ending gets changed to "ide." We just insert that Roman numeral after the name of the cation that specifies what the charge is on that copper ion. Okay, let's look at another example. Fe2O3. So you're going to start with what you know, and what we know is the charge of the anion. We know that oxygen likes to form ions with a charge of -2. Again, you're able to determine this using your periodic table and using the octet rule. Atoms in the 6th group on your periodic table tend to form ions with a charge of -2. Looking at the formula, we see that we have 3 oxygen ions. That means the total negative charge from the anions is -6. We can use this to figure out the positive charge on the iron ions. But when we look at the formula, we see that we have 2 iron ions in the formula. That means that the sum of the positive charge from both iron ions must be equal to +6. Which means that the charge on each iron ion would be equal to +3. The charge of the ion is what you use for your Roman numeral in the name of the compound, so this would be iron 3 oxide. And if you notice, we don't use the total positive charge from all of the cations. We just use the positive charge on one ion. So when we look at the name iron 3 oxide, that tells us that all of the iron ions in this compound have a charge of +3. Now would be a great time to pause this tutorial and to try to determine the names of these ionic compounds, including the Roman numerals, because all of these examples here include transition metals. Okay, let's go through these examples. Looking at the first one, CuCl. I know that chlorine likes to form ions with a charge of -1. That means in order For this ionic compound to be neutral, the copper ion must have a charge of +1. So the name of this compound would be copper 1 chloride. Moving to the next example, MnO2. I know that oxygen likes to form ions with a charge of -2. There are 2 oxygen ions in this compound, so the total negative charge from the anions is -4. That means that the positive charge on the manganese ion must be equal to +4 in order for this ionic compound to be neutral. So the name of this compound would be manganese 4 oxide. Looking at the third example, Mn2O5, again I know that oxygen likes to form ions with a charge of -2. There are 5 oxygen ions in this compound, so that means the total negative charge from the anions is -10. In order for this compound to be neutral, each manganese ion needs to have a positive charge of +5. And remember, it's the charge on the individual cation that determines the Roman numeral used in the name. So the name of this compound would be manganese 5 oxide. Looking at the last example, sulfur tends to form ions with the charge of -2. There are 3 sulfur ions, which means the total negative charge from the anions is -6. That means that the positive charge on each chromium ion needs to be +3 in order for this compound to be neutral. So the name of this compound would be chromium 3 sulfide. Thanks for watching the chemistry solution. We hope you enjoyed this tutorial. Look for part 2 of naming ionic compounds, where we look at examples with polyatomic ions, coming soon.